examples of manipulating the temperature to disrupt the equilibrium of a system. So here is our system at equilibrium. And in this case, we're going to cause an increase in the temperature. So there's our stress. It's an increase in the temperature. So if it's a change in the temperature, then heat is the stress. And if the stress is an increase in the temperature, that means it is an addition. The stress, the heat, is on the reactant side. And if it's an addition, then the system will shift away from the stress. So the system in this case is going to shift right. Now, why does this happen? Well, it's an addition. The system was forced to have an increase in the temperature. That means more heat was added. So now we have extra heat. So now the system has an extra heat. The system has to use the extra heat. So the system has to use up the extra heat. And the way the system uses it up is by absorbing it. So the heat must be absorbed. So the way it uses it is that the reactants, same side as the stress, so our forward reaction is favored, meaning that the reactants are going to react to make more of the products. So in the reaction of I2 and H2, so in this forward reactant, the reactants absorb the extra heat to make the product. So if the reactants are participating in a reaction, that means they're being used. So their individual concentrations will be decreased. And as they are reacting, the extra heat is being absorbed or used. And as a result, it ends up forming more of the product. So its individual concentration will increase. So down here, now for this system, if we decrease the temperature. So whenever we manipulate the temperature, we find heat. So this is the stress. So this stress, because the temperature dropped, it is a removal. The stress is on the reactant side. So if the stress is a removal, the system will always shift towards the stress. So that means the direction of the shifting towards the stress, the system is shifting left. So the system will shift left. So now in this scenario, there's not enough heat. So the system has to replace the missing or removed heat. And the way that the system replaces the heat is it needs an exothermic process. So the exothermic process is the reverse reaction. So in this case, to reestablish equilibrium, the reverse reaction is favored, meaning that the products will make more of whatever is on the reactant side. So HI, the product, HI will release heat as it decomposes into the reactants. So the HI is being consumed or used, so its concentration will decrease, and the H and the I in the molecule don't disappear, but they show up as elemental iodine and elemental hydrogen, so the individual concentrations on the reactant side will increase, and because it's an exothermic decomposition, the heat that was removed is now being replaced.